Hello, today we're going to start talking about special right triangles. We've already talked about them a little bit, but today we're going to start looking at them in terms of their trigonometric ratios. Okay, so our objective is students will be able to understand that if alpha and beta are measurements of complementary angles, then sine of alpha and cosine of equals cosine of beta. The students will be able to use the relationship with special right triangles, and this is what we're going to focus on, is the relationship with special right triangles. The vocabulary you'll hear frequently are right triangle, right angle, acute angle, opposite side, adjacent side, hypotenuse, similar triangle, sine, cosine, and tangent. All right, we're going to jump kind of right into an example, but more of a discussion. And so there are certain special angles where it is possible to give you exact values of sine and cosine. These are the angles that are measurements of 0, 30, 45, 60, and 90. So I'm going to highlight sort of the pairings that work well together. 0 and 90, 30 and 60, and 45. Okay, and if we go back to our objective, if we think about these in terms of their complementary pairs, the 0 and the 90 pair up, the 30 and the 60 pair up, and there's a single 45, but if we think about it, 45 plus 45 is equal to 90. Now, I know it's not something that you like to do, but you should memorize the sine and cosine values of these angles. You don't have to, and we've discussed already in class the relationships and how you can get to them. So I'll reiterate that within the video, but if you do like to do things more quickly, here's a table to memorize. So sine of 0 degrees is 0, sine of 30 degrees is 1/2, sine of 45 degrees is square root of 2 over 2, sine of 60 degrees is square root of 3 over 2, and sine of 90 is 1. On the flip side of that, cosine of 90 degrees is 0, cosine of 60 degrees is 1/2, cosine of 45 degrees is square root of 2 over square root of 2, cosine of 30 degrees is square root of 2 over, or square root of 3 over 2, and cosine of 0 is 1. Okay, and so if you'll kind of look at the chart, the colors sort of help you coordinate the values that will end up being shared but different. Okay, so if you're looking at these, I noticed that the 60 degree has a square root 3 over 2, but so does the 30. It's just in a different location, right? And the 1/2 shows up right there. And so that's kind of an important connection as we get through this. Okay, we may focus on an easy way to memorize this table, and you can kind of look at it like this. The sequence of 0, 1/2, square root of 2 over 2, and square root of 3 over 2 may be easier to remember as this sequence. And if you think about this sequence, square root of 0 is just 0, so 0 over 2 is 0. Square root of 1 is 1, so 1/2. Square root of 2 stays over 2. Square root of 3 stays over 2. And square root of 4 is 2, but 2 over 2 is equal to 1. And so what this is numerical order. Okay, so 0, 1, 2, 3, 4. That can help you. I do have one additional way. It's kind of like this. It goes 1, 2, 3, 3, 2, 1, square root over everything, and then divide it by 2. And what this is the first row is your sine of theta. If theta is equal to 30 degrees, 45 degrees, and 60 degrees, and here's your cosine of theta. And it's just a table, kind of help you stay informed and organized. Notice it doesn't give you the value of 0 and 90, but it's just another way. It's like it's got a pattern to it though. Okay. So as we look at the next problem, this is kind of what I was talking about. We've gone through similar fundamentals on how to do this. So ABC is an equilateral triangle with side length 2. If we drop this perpendicular, it just so happens the perpendicular creates a bisector, and so we have a 1 and a 1. And it says, use your figure to determine sine and cosine of 30 and 60. We know that an equilateral triangle has all three angles of 60, but since this was bisected, that's 30 and that's 30. And if you look at this, now I have a 30, 60, 90 right triangle with a hypotenuse of 2. And we can use this to determine the values of sine and cosine. But before I do that, I do need to make sure that I find this hypotenuse value. We've done it with Pythagorean theorem work that we did. So 1 squared plus h squared equals 2 squared. 1 squared is 1. H squared equals 4. H squared equals 3. And therefore h is equal to the square root of 3. So this altitude, the height, is square root of 3. Now how does that help us? Well, it allows us to set up the sine and the cosine values if I've identified things at 30 degrees and when I identify them at 60 degrees. And so therefore you don't technically have to memorize your work. It just makes it easier. So if I'm looking at this as the pink and I draw the line, this is my opposite. This would be my adjacent. And my hypotenuse is always the same. So I can just label this hypotenuse. I know that sine of 30 degrees is supposed to be opposite over hypotenuse. So sine of 30 is opposite, which is 1. Hypotenuse is 2, so sine of 30 is 1/2. If I look at cosine of 30 degrees, that's adjacent over hypotenuse, which is square root of 3 over 2. So cosine of 30 degrees is square root of 3 over 2, which mimics what we've seen in our table. And maybe we noticed those patterns before in our mathematical work. Next one you want to look at is the 60. So if I do the same thing, this would be my opposite, this would be my adjacent. And notice I'm color coding these just to make it a little bit easier. So sine of 60 degrees is equal to opposite over hypotenuse. And that would be equal to square root of 3 over 2. So sine of 60 degrees is square root of 3 over 2. And cosine of 60 degrees is equal to adjacent over hypotenuse, which is equal to 1 over 2. Because my adjacent is 1, my hypotenuse stayed 2. And so you don't need to memorize those tables, but the tables just make this work a lot quicker so that you don't have to draw out an equilateral triangle, bisect it, etc. As we continue on, the next problem kind of indicates the 45-degree angle. So what I have here is an isosceles right triangle. So that's really important. What does that tell me with legs length 1? Is that this side is 1, that side is 1. Again, you have to use Pythagorean theorem to figure out the hypotenuse this time. And so 1 plus 1 equals AC squared, 2 equals AC squared, and square root of 2 equals AC. So this is square root of 2. Now how does this help me? Because I can now pick either angle, and since this is 90, the remaining angles are supposed to be identical. 90 divided by 2 is 45 degrees, so this is 45 degrees and this is 45 degrees. And I can now use these ratios, as we've learned in class that all isosceles right triangles will be similar with a different scale factor to this unit one. And so sine of 45 can be determined using these ratios that you already have. So 45, here's my opposite, here's my adjacent, And it doesn't matter which one I'm working with, they're both 45s. So sine is opposite over hypotenuse, which is 1 over square root 2. And a little note, we generally rationalize any value with a radical in the denominator. So square root 2 over square root 2, and so I get square root 2 over 2. And that's how they got the ratio on the front page for you. Cosine of 45, it's a very similar process. Adjacent over hypotenuse though. I know my adjacent side is 1 over square root 2. We rationalize that and you get square root 2 over 2. And so the cosine of 45 matches the cosine of sine. And it's really to do with the fact that these two values are identical. And so what they've done is they've summarized these tables and they said, well, what happens if I have this ratio of 1 to radical 3 with a 30, 60, 90 triangle, and this would be a leg. The 2 is your hypotenuse, and the other one is a leg. And so the x comes into play as we start thinking about the fact that we don't only have to have integer scale factors. And so what these represent are your scale factors of your similar triangles. Okay, and the similar conversation could be had about the 45, 45, 90 triangle, and it's 1, 1, square root 2. And so this is your leg, this is your leg, and this is your hypotenuse. All right, a couple problems for you, and then we'll be done with the video. So example number 1 into find the missing side lengths of the triangle. So right now I know that this is 30 degrees, which means this is my opposite, this is my adjacent, and here's my hypotenuse. And so if I think about this in terms of sine of 30 degrees, that's going to equal opposite over adjacent, opposite over hypotenuse. Sorry, going too quick. Sine of 30 degrees is opposite over hypotenuse. Well, we've just gotten done talking about how these will relate. And because they're similar triangles, the ratio itself is always going to be the same. If we look back at our work, the sine of 30 is 1/2. The opposite value is a, and the hypotenuse is 3. So now I can use cross multiplication. I don't like that term. I can multiply both sides by 3 though, and I do get 3/2 equals a. And that's one value. And then we look at the cosine of 30 degrees. We know that that is the adjacent over the hypotenuse, and that means b over 3. Cosine is the square root of 3 over 2 over b over 3. Multiply both sides by 3. You get 3 square root 3 over 2 equals b. Check. And if I wanted to check this, what I could do is do 3/2 squared plus 3 radical 3 divided by 2 squared and see if that equals 3 squared. Okay, 9/4 plus 9 times 3 is 27/4. Does that equal 9? 9 plus 27 is 36. 36 divided by 4 does equal 9, so 9 equals 9. Check. All right, last problem. Now a little bit of this has changed because if we follow the same pattern, sine of 30 is opposite over hypotenuse. That's going to be a divided by c. And I have two variables here, so actually what this implies is we have to start with cosine. So you do want to start thinking ahead of where the variables are and what you're being asked to solve for. Cosine of 30 is equal to adjacent over hypotenuse. The adjacent side, and I didn't even go through this, sorry, is, there's my opposite. My adjacent side is 3 So 3 hypotenuse is C. I know the cosine of 30 is always going to be equivalent to the ratio of square root of 3 over 2. I get square root of 3 times C equals 6. C is equal to 6 square root 3. And if I rationalize this, I'll get 6 square root 3 over 3, which is 2 square root 3. So C is 2 square root 3. Now I can reuse sine. So sine of 30 degrees is equal to opposite over hypotenuse. Opposite is A. Hypotenuse is 2 square root of 3. Sine of 30 is 1/2. So I do a little bit of this work. 2 square root 3 equals 2A. Divide both sides by 2, so square root of 3 is equal to A. And so these are my solutions. And we should always check our work. So let's look at this. I know one side is 3. The other side is square root 3. Does that equal 2 square root 3 squared? So that's 9 plus 3 equals 4 times 3, 12 equals 12. Check. Okay. So this is really important as far as like making your life much easier, being familiar with how the triangles connect back to the ratios that you've been working with. That's also really important. So take your time, summarize the notes, make sure you can memorize or create a system that you can memorize the 30, 60, 90, and 45, 45, 90 ratios. Thank you for your time.